Welcome to this tutorial. This tutorial focuses on something called electron configuration. This is a very fancy way of just talking about how electrons are arranged in the spaces or shells around the nucleus of an atom. How is it that we could make simple drawings of atoms? We'd have to know where the protons and neutrons go, and we'd have to know where all the electrons go. So let's have a look at an example using the atom sodium. Sodium has an atomic number of 11, that is, it has 11 protons. In an ordinary neutral atom, the atom will have the same number of protons and electrons. So sodium also has 11 electrons. It has also 12 neutrons. So where would we put the protons and the neutrons in an atom? Well, you've already learnt that protons and neutrons go into the middle of the atom, the nucleus. So for sodium, we would draw 11 protons and we would draw 12 neutrons in the middle of the atom. But how would we arrange the 11 electrons around this nucleus? There is a fairly simple rule to help us to understand where these 11 electrons can go, or where any electrons can go in an atom. The rule says that in the first shell or space around the nucleus of an atom, that a maximum of 2 electrons can be held. So the first shell, we'll call it this space here, the first shell around the nucleus of any atom can hold up to 2 electrons. This first shell is also referred to as the K shell. So in the first, or K shell, can be found up to a maximum of 2 electrons. Once 2 electrons are put into the first, or K shell, then it is full. This area of the first shell cannot hold any more. So if you have more than 2 electrons for an atom, then you've got to move out to the second shell. The second shell or space around an atom, second shell, or the L shell, can hold up to 8 electrons before it's full. So a maximum of 8 electrons can fit into the second, or L shell. Once 8 electrons are in this shell, then it is also full. So if you have more than 10 electrons, that is 2 in the first shell, 8 in the second, if you have more than 10, you're going to need to go out to the third shell. That is the third, or the next space around the outside of the atom. So in the third shell, also referred to as the M shell, you can fit, theoretically, up to 18 electrons. However, it has been discovered that atoms can only take 8 and remain stable. After they have 8 in the third shell, any further electrons will move out to the fourth shell. But theoretically there's enough space in the third shell to hold up to 18 electrons. So for sodium, there are 11 electrons that have to be placed. So we would put 2 of those electrons into the first shell. The next 8 electrons will go into the second shell. And because there's 11, there's still 1 more electron to place, so it will have to go out in the third shell. So sodium has 11 protons, 12 neutrons in the nucleus or middle of the atom. Its 11 electrons are arranged with 2 in the first, or K shell, 8 in the second, or L shell, and 1 in the third, or M shell. So its electron configuration can be written as 2, 8, 1. 2 in the first shell, 8 electrons in the second, and 1 electron in the third. Let's have a look at another example. Let's have a look at carbon. Carbon is number 6 on the periodic table. Carbon has 6 protons, 6 neutrons, and 6 electrons. So what do we place into the middle of the atom? So we'll have the 6 protons and 6 neutrons in the middle of the atom. 6 protons and 6 neutrons in the nucleus of the atom. We have 6 electrons to arrange around the outside. You learnt just a few minutes ago that a maximum of 2 electrons can fit into the first shell. So we will place 2 electrons in the first shell around the nucleus. But carbon has 6 electrons, so we have another 4 to place. So we will place the remaining 4 into the second shell. And that's it. That's the 6 electrons for carbon. So this is a simple representation of the carbon atom. Let's have a go at another example. Let's have a look at chlorine. Chlorine is number 17 on the periodic table. It has 17 protons, 18 neutrons, and 17 electrons. So into the nucleus of the atom, into the middle, we will have 17 protons, and we will have the 18 neutrons. And we have 17 electrons that have to be arranged around the outside. So how many electrons can fit into the first shell, the K shell, of this atom? Hopefully by now you've worked out that a maximum of 2 electrons can fit into the first shell, the first space around this nucleus. So that uses up 2 of the 17. That means we have 15 electrons still to arrange. The maximum number of electrons we can fit into the second shell is 8 electrons. So we'll put the next 8 electrons out into the second shell, or the L shell. So we've now used up 10 of the 17 electrons. We've still got 7 more to place. Now the third shell can hold up to 8 electrons, and we only have 7, so we can put the remaining 7 electrons out into the third, or M shell, of the atom. And this is it. This is the completed representation of chlorine. So we have 17 protons, 17 neutrons in the nucleus, and we have the 17 electrons arranged, 2 in the first shell, 8 in the second, and 7 in the third. So the electron configuration of chlorine is 2, 8, 7.